In this video, we're going to find a unit vector, a vector whose length or magnitude is 1 that has the same direction as this vector here. Now, before we even start worrying about vectors and all that, let's just look at a couple of lines. So first, let's look at the line that goes through this vector OP, this vector here. So the line that goes through that is the line that you can think of as just covers that thing there. Okay, now the point P is on that line. That's the point 5, 2. And also this goes through the origin, so 0, 0 is on there. So we can find the slope of this line. M is equal to, let's see, y2 minus y1 over x2 minus x1. So we can think of this as 2 minus 0 over 5 minus 0, which is 2/5. All right, so the slope of the line that goes through our vector OP just continues right through it in both directions. The slope is 2/5. Now let's look at a completely different line. Well, and that will be the line that goes through 0, 0, and the point 5 over 7, 2 over 7. Now this will make sense why I'm doing this in a moment. So we just have this line going through there like so. So let's find the slope of this line. Let's see. y2 minus y1. So our y2 is 2/7 minus 0 over 5/7 minus 0. Let's see, that's 2/7 divided by 5/7. That's 2/7 times 7 over 5, which is 2/5. So we get the same slope. So in fact, these have to be the same line, right? Because they both go through the origin, and they both have the same slope. So they must be the same line. So the point of all this is that we can divide 5 and 2 by anything, as long as it's the same thing, and we'll stay on the line that goes through 0, 0 and 5, 2. So if we want to make a unit vector, a vector that has length 1, that goes in the same direction as this blue vector here. Essentially what we need to do is we need to figure out how much to divide 5 and 2 by to get a vector with length 1. And so the idea, let's say this vector has length 1. And so what we need is 5 over what? 2 over what? And so if we divide them by the right thing, the right number, that'll scale this vector back down to having length 1. So again, what we need to find is how much to divide 5 and 2 by to have a vector with length 1. So what is that we have to divide them by? And the answer is the magnitude, or the length of this vector OP. So let's find the length or magnitude of this vector OP. That's exactly this vector here, right? So P is the point 5, 2. Remember, magnitude is the length of this arrow, the length of the vector, how long it is. Right, so this distance here, the x distance is 5, and the y distance is 2. And then we can label this distance c, right? So that c is the length of our vector OP. O being the origin, right? Remember, this is O. So 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. 29 equals c squared, and c equals root 29. So that tells us that the vector that has, so the vector that starts at the origin and goes to this point here, what will this point be? This will be 5 over root 29. Two over root 29. That vector with initial point, the origin, and terminal point, 5 over root 29, 2 over root 29, this vector, it's definitely going in the same direction because it lies on the same line as OP. But we're going to see that its length, its magnitude is 1. And why is its length 1? Because we're dividing everything by the overall length. All right, so let's see what that is. Okay, so now let's again draw a triangle. Let me draw it in blue here. Let's just say red. So the red triangle there. You can say A, B, and C is that length, right? So A squared plus B squared equals C squared. A squared, let's see, A, the length of A, that's this distance here. So that's 5 over root 29 squared. B is that distance there. That's A, that's B. 2 over root 29 squared. Now see what happens here. Let's see. Squaring this, right, we get 5 squared over root 29 squared. That's just 25 over 29 plus 4 over 29. And so now you see what happens, right? 25 plus 25 over 29 plus 4 over 29, doing the math there, right? We get 29 over 29 equals c squared. Taking this, so 29 over 29 is 1. Right, that's equal to 1. So c is equal to 1. So in fact, we found a vector whose length is 1, a unit vector, and it has the same direction as OP. Now writing OP in component form, right, we could give these all names. We could say V is the vector OP. Writing that in component form would be 5, 2. Let's give this point right here a name. Let's call that Q, that point Q. So Q is that point. This is OQ. It's 5 over root 29, 2 over root 29. So essentially, to recap, what do we need to do, right? What do we need to do if we want to? So I just went over all the concepts of how to do this. Basically, what you have to do, right, is let's give this thing a name, V here. V, written in component form, is 5, 2. The magnitude of V is the square root of 5 squared plus 2 squared, which equals root 29. So then the answer to our problem, finding a unit vector in the direction, same direction as V, is we divide by this magnitude. And that's our unit vector in the same direction as V.